Alright, lab 1, constant velocity. The purpose of this lab is to create a code to mimic real life observed data. To do this, plot a time to position and velocity graph using Newton's laws and position update formula. What's what? In the experiment, the system is an expo marker and surrounding forces with the contact force from the table and various forms of gravity that weren't really taken into consideration in calculations, but the movement starts off by me pushing the marker with my fingers and we started recording after a certain amount of time. How do we get the position and velocity? To find initial force, velocity, and position, I use a tracker app tracker app on a group. I use a tracker app on a video of us pushing the marker. The vectors with values were velocity and position, while force came out to be zeros all across the board. And since force is constant, we should use V average instead of V final. And these are the equations for both, formulas for both. What did I do? My code involved the use of velocity update formula. V final equals V initial plus F net divided by M times delta T, and the position update formula. Our final, R final plus R initial plus V average times delta T. Since force is constant, force doesn't change. Initial time in the video was 2.125 seconds. Delta T starts off at a hundredth of a second, increases by hundredth of a second every time position is updated until time equals 2.395. In between the times, the code is constantly updating the velocity and using constant force, and initial velocity. Well, the equation uses the constant force and initial velocity to get V final, and V final minus V initial over 2 gives you the V average to use position update formula. But the V final from the velocity update formula becomes new V initial, then the process starts over again. Also, every time the position is upgraded or the restart happens of the loop, V final and position final are recorded and plotted on graphs seen before. This one's position and this one's velocity. And this is the code. You can pause the video if you want to look at this longer. In discussion, in regards to what the plots look like and simulate, what's same is the velocity didn't change and stayed constant because force was equal to 0 after a certain amount of time, and the position had a linear increase in the x component because velocity was also constant. And if the negative x and positive x were flipped, then the plot would look like it would be flipped across the y-axis. On the other hand, the initial position vector is kind of a wild number due to inexperience with tracker. It doesn't really make sense. And also, the calculations for the plot would work entirely if the experiment wasn't ran as if it were in a vacuum, because the experiment doesn't account for friction or any forces of gravity.